Today is Vladimir, and he's CEO of DataWorkshop and also host of Business Myśli podcast. And he will show us how to self-host our own LLM service. So, Vladimir, the stage is yours.
Yeah. Hello. 1 1 1 2 3.
Hello. What about your energy? The last presentation very yeah, that's fun. Let's start. So I will interact with you just to be sure that you don't sleep. First question. This is about from yesterday's slide I found. So two questions. First question: have you heard about ChatGPT? Like, raise your hand. Have you heard it? Okay. And second one: have you used it? Because in general it looks like quite standard, but turns out that it's not actually. It's true. For example, in Poland, it looks like only 1/3 people use it, and less than half heard about this. It's a bit crazy because for me it's kind of like normal day, and I was surprised that reality looks like a bit different, and we are in the bubble, and we should be aware about it. My name is Vladimir Alekseichenko, and here is what I'm thinking about how to run things in the cloud. Everything is good, and here is when I'm trying to do it and a bit more tired. So today I'm trying to share with you my experience, what I learned. A lot of mistakes happened. This is a bit quiet topic. I don't know everything for sure, but probably I learned something, and I will try to share it with you. Have you heard about podcast Business Myśli? It's good. I know that there is podcast is actually in Polish, but last episode all about LLM. So I recommend it to know. So let's go. About OpenAI. So I've asked who used it, and if you check here, like monthly web active user, we have more and more, but still it's like 2 billion. It's quite large numbers, but it's not unique. It's like active, monthly active, right? And people in planet probably a bit more, but it's quite impressive number. The problem is to run those things is a really big challenge because from our point of view, it's like normal website. We try to type something and get some answer, but running those stuff under hood is quite complicated. Sometimes ChatGPT is really useful, and not only ChatGPT, but the thing is like this. Sometimes it's useless, and in Ukraine it happened. And by the way, who used ChatGPT or any other LLM for coding? Wow. Are you feeling in the same way, or is it better? It happened? Sorry?
It depends what you ask for.
Okay.
If you ask for small things, you want big.
Okay, small thing works, but if bigger, like 2 files, it's okay. Okay. Now, from active point, if you look how it looks like active like this, so it's quite simple to run. And from this point of view, we need just decide about keys, just copy paste key, and decide about model, and type some prompt if we need. And after we run this code and we use this capable model available for everybody, we are feeling like this. And by the way, after running this code, we can proud that I'm engineer, AI engineer now, and it looks funny, but what is really important in terms of understanding some terms? So right now, when we talk about LLM, ChatGPT, it's only part of the whole story, and actually ChatGPT is even smaller part, for example here. But on the other hand, in terms of trends and how people in general to see the world about AI, about ChatGPT, it looks like first AI was on above, and later ChatGPT actually is more popular than AI. And right now, first of all, ChatGPT is synonym AI, and even it looks like going up. So this is a bit crazy in terms of ChatGPT. It's really kind of small things, but in terms of how reality looks like, in terms of trend, it's actually about AI. And yellow here, this is Ollama. So if you say somebody else not in this room that you do something with llama, it's a bit crazy. What is it, llama? It's animal always. But if you say ChatGPT, probably somebody will hear it. But as I mentioned before, for example, in Poland, half people doesn't hear it. All right, but the hint is people from running this prepare some servers, GPUs, and other stuff, and this man, for example, can run it. But what if you won't run by yourself, right? The question is, why you need other model? For example, why ChatGPT or GPT in general is not enough? Because if you check Arena leaderboard, have you heard about Arena leaderboard? Have you heard of it? Okay, it's kind of, let's say, number one leaderboard in general in terms of comparison. There isn't a full leaderboard, but there are something. We usually compare in Arena leaderboard. And if you look at, for example, from today, I made a screenshot from today. And if you look at here, you see that OpenAI is quite popular in the top. And the question is, why you need something else? It works, right? Why you care about change something? Sometimes ChatGPT actually in May, this happened. Sonnet Cloudy free deploy a new model, and there are some title like King is dead or almost. But OpenAI is still on the top, and the last model Strawberry keep this place the whole time. Now, let's repeat this question. If ChatGPT or GPT in general is work very good, why we should care? Why we should create, or why we try to create something else than just use it, what works? And there are many reasons. One of them, probably the biggest one, is vendor lock. And this is not good in general, not only in software, but in general. About some issue about data privacy, about control stuff. Because actually what we can decide about model, like model name, but on the other hand, nobody guarantees us that this model will be working the same time, in the same way during the whole time. For example, if I ask the same model today and ask the same like 1 month later, I will receive the same because model name is the same, but they probably replace something. Another thing, sometimes we have to this. So sometimes those people decided to change something, and they don't ask about you. That, for example, you spend, let's say, 1 year or more to prepare some prompt for GPT-3 half and half. This is actually a bit tricky model and required much more complicated prompts. And for example, you prepare those prompts and you don't want to change anything, but somebody else decided that, for example, this model can be not available or will be available with some limitation. So this is not good in terms of controlling stuff. Another idea in general about experience, about like topic which we should consider, the new model, Strawberry, you have heard about this new model, right? O1. So this model about reasoning, like in terms of LLM, reasoning is quite important topic. And in practice, that means that we try to ask things on an inference level. So we have one level is like training model when we learn some facts, and another phase is like, okay, we have this model, we have some facts, and let's try to ask some things, and in this way try to find the answer. So in general, O1 is used by code. Actually, we don't know what they do, but it is what they say, like something like this, and some tricky stuff inside. There are more complicated stuff related with chains, like SOT or whatever. It's much more complicated, but the idea is simple. The idea is like we ask something, we got answer, we ask again, use this answer, and so on and so on. And in this way, it's like normal human. Like we ask something, think about this, ask again and again, and so on. So in terms of inference, That means it's quite an important topic. Like we will need more and more understanding how to do it efficiently. This is why it's worth to think about this. Yeah, this is like some information what actually happens when it's this model appear. Yeah, hence all time inference computing will be much more important in terms of understanding. And last but not least, argument why we want to do it, because we can, right? This is quite good argument. If you can try, why we shouldn't. But before we start about discussing how to do it, it's a bit difficult. But what I said, I don't know the answers for the whole question. I try to find something what is really useful to run some models to reuse it. This is quite a good one, but we should remember that this topic is quite complicated. But the good news, the light is in there. The long story in short, here is LLM model, and we type it in our server. So this is actually the whole story to understand better what's going on. Now, finally, for example, again, we don't know what OpenAI do, and we don't know how much GPU cards they use to serve this traffic, what they have. But some information we have. And for example, we can say that more or less 300 key H100 cards needed for just serving result for people who would ask GPU. And this is about Meta. Okay, this is about another stuff that Meta also needs GPU to train Llama, and those quite a lot of cards they bought in January this year. And this is actually what happened on the market, that more and more GPU powers is needed, and not those GPUs available for everybody. And the problem is also about small company, for example. By the way, if you are working small company or you're some startup, can you try and get access to GPU in big cloud and how it works? It works normally. For example, if you want to train some models and you need like few of these GPU cards, it's easy to get it. I don't know now because I don't try it because I tried like 2 years ago, 2 years for example, or one even. It's a bit hard to get this access. For example, in Google Cloud, you have only one region, I guess, for example, in one region in Europe, and you have general GPU, but when you try to get access, this is a bit complicated. So this is sad stuff, but it should be good. Even Microsoft, Satya Nadella, complains that we have too much, like in terms of OpenAI, we have too much activity on the OpenAI. This is a big challenge for us in terms of GPU. And what's happened in terms of capacity? This is about OpenAI right now, on the OpenAI. So once they started, they have around so stable. Right now, they have, for example, somewhere here, and this is about plan about next stages. Here is some summary. So right now, they have a plan to have 2 million GPU in this year, but still most of them somewhere in the factory, I don't know. Yeah, and in the end, 27, they have a plan 7 million here. Just to be sure that you understand those numbers. For example, I'm trying to calculate how many GPU cards exist in Poland in some university, like big university. Do you know how many? How many GPU in summary they have in Poland? 1,000. Around 1,000. Around 1,000. 1,000. Only 1,000. So it's like, in the parallel world, we have Elon Musk, and what he actually did in the 4 months, he created a data center and collected GPU. You know for what? You know company? Yeah, exactly. So and they built like in 4 months a new data center. Right now they have 100, and they want plan to add another one. For example, in terms of Xi, it looks like Xi even has better position in terms of capacity
Yeah.
in terms of capacity and yeah. Now, another story about market, Oracle Cloud. Have you used Oracle Cloud? Have you heard about Oracle Cloud? Have you used it? Because I know that it exists, but never used it. But, but on the other hand, what happened? They tried to create a really huge GPU cluster, and for me, it's kind of game changer. I don't know what happens later, but it sounds like something will change because right now, no, this won't happen. It will happen in the Neuralink 25. But when it happens, they will have more GPU than other big clouds like Amazon and so on. So it's kind of a big challenge for now. So let's decide that you want to buy GPU. Why not? So this is what I'm trying to do. I type in 100 store GPU, try to find. So here is the price. So the thing is quite simple. By the way, there are only three. And I'm trying to compare it's expensive or no. So I'm trying to find some cheap cards. And as you see, you have choice what to decide to buy this card or to buy this card. But it's quite clear what you should do, right? And you have only three. And here is you have almost 1,000. You know. Now,
To others, NVIDIA is discontinuing production of 49 bits, and Chinese people are exchanging the chips to boost the capacity of DRAM to double the amount.
Yeah, they have the good point because 100 H100 card cannot go to China, and they change it, and they have right now H20. And this is a bit smaller in terms of processor, but it is better. It is better in terms of VRAM, more than 100. Okay, but you know, even if decided on 100, it's still not enough because if you try to run Ollama, if you pick one Ollama, you will see this exception. By the way, how often do you see this exception? Exactly. This is kind of you want to kind usually. It's like free emoji. This is that moment usually. Yeah, this is where we are. Now, GPU now is not much more than only hardware. GPU is changed the world. A lot of people and bloggers. By the way, I don't know if you heard about it, but it's about fashion as well. Chanel and so on, it's not popular right now. You can buy like the GPU and $1,000.
Like $20
or 1,000 here.
yeah, but the chip or the whole card at the bottom of eBay is like $20 or $30.
Ah, okay. Yeah, that's right. Okay, this is a bit funny, but let's go deeper. It should be more technical and talk as well. So how to approach throughput optimal setting? This optimal is a bit tricky because the thing is it's really hard to run a large model in optimal way because you have few parameters like relatively small, but if you change one or second one, everything can be works or disturbance. It's kind of like this. But let's try think about how it works under hood. First thing, when we talk about inference, we should understand that we have two phases, one phase and second. One phase is about understand prompt. So we type some prompt. And model should convert this prompt, and this is the phase when it's CPU bounded. So we calculate the stuff because, for example, we have long context and we calculated the whole long context. But on the other hand, we have second phase, and second phase is about generated new token. And we can generate new token after we create first one, we generate the second one, later the third one, and so on and so on. And this is more about memory because we should copy stuff between those steps. And this is, by the way, why it happened. When you try to analyze pricing in terms of context, you can see that context has two types, input and output. And price for input, this is in blue one, is much cheaper than price for output, especially for a new model GPT, Strawberry. And why this happened? Because it's two totally different phases in terms of resource optimization. And when we talk about engine, which optimize the hub, they focus a lot on the second step because a lot of things can be improved on the second phase. Now, let's try and understand better what type of decision we should make if we decided to run the model, local machine, on server, what we decided. I'm trying to put some steps. Actually, some of them quite big, still quite big, but right now at least we have some logic to talk about separated steps in terms of what we should decide. Because I think most people heard about like running LLM in GPU, or you can use vLLM or TensorRT or whatever. And sometimes, for example, for me, it was a bit complicated to understand, okay, about what we're talking, because sometimes we compare one thing with another thing, and I don't know we can compare those stuff or this is like not comparable. And this is why I prepare some structure, at least for me, and share with you how we can think about this. So we have those 5 steps, API, and it will be good if it will be compatible with API OpenAI. This is actually created right now slide because somebody asked why we created API like based on OpenAI. And actually, it's very easy in company create a new standard because we have ideas, right? Right now, we create something new, it will be really cool. But this is actually happened in this way. We have before 14 standards, and after we have 15. This is why really we don't need to create a new standard. We just should reuse each one that works. And slide create like a few seconds ago, few minutes ago. Okay, let's try figure out in terms of those structure where we are when we use OpenAI model. So when we use OpenAI, we decided only about this. We decided only which model we want to use. So in practice, it means that this one, this in red, somebody else care about this. We decided only about this, but not actually like the whole area about model, because first of all, we can decide that we select from list which OpenAI available for us, and this list can be changed in meantime. Or sometimes, for example, O1 is not available for everybody. You should pay a lot or to do something to get access, for example. And another thing, even if you use the same model as I said before, you cannot any guarantee that physically it's the same model. Because I know that model can work in probability case because it's about LLM, it's okay. But I talk about something different. I talk about that how I can, is it possible that OpenAI will guarantee me that this model physically will be all times the same? Actually, no. Now, let's go in another journey. Let's say we want to decide it, the whole path by ourselves. So first one about hardware. Right now, if you talk about markets relatively hardware, of course, NVIDIA almost has 100%, but there are some small another company which try to do something. For example, I prepare this mind map. And here is, for example, okay, about metal, this is what the first presentation was before. And by the way, I will show how to run Llama like 400 million on the max. Quite funny, but it's possible. Also, AMD. This is quite good in terms of number of RAMs. Quite big. For example, again, H100 has only around 80, and sometimes it's more, but it's like double more. And there are another like chips only related with again from TPU is by Google made, and another one. Oh, and here is video related with, so we have Llama 400B, we have 2Max, we have Exxon, and we share those information between 2Max, and it works. Okay.
So it's 405 billion, which and it's between the two. And you can see that it's a larger model being a little bit more.
Okay, the idea is it's possible. You can run even two models on
Teamsy musisz wyciszyć.
Now, let's go. Let's look on this table. So we have some GPU cards, NVIDIA, for example, AMD. Few of them, for example, this one is most interesting. And the most popular, of course, is H100 or A100. Probably those is the most important. And we have for this card 80 gigabytes RAM. Now, I don't talk about buy. I showed if you want, you can try. Confluent, for example, but they can be free. But let's go, if not buy, what else? So let's try to rent. What is possible options we have? So first of all, we have big clouds, but what I said before, for big clouds, usually don't have a lot of GPU, by the way, but usually don't share for small startups, or it's more complicated, let's say in this way. And this is why some another options appear. That's why the best options is RunPod. I will, if you will have time, I will show some demos about this RunPod. And there are another one which can be useful. Now, if you talk about RunPod and talk about some price, RunPod has H100. It's around $1 or $3 per hour. This depends by configuration. For example, secure cloud or community cloud. Secure cloud gives you some pure level more than community cloud and so on. But if you don't run something special, you can go on community cloud as well. So here is about 80 gigabyte RAM. Here is about almost half 100 gigabytes, and the price is $50. So those prices quite good compared to the price I shown before, and it looks like I can run something and use it more actively than just buy. If you buy a car, this is only one price because you need only also energy, and it's quite expensive as well. Also, there is options like serverless. The idea is quite simple. So first option, we pay by hours. For example, if you run GPU for a few hours, you pay by hours. For serverless, we pay when we use it. And this actually can be running full time, like production. And we can send our prompt when we need. And for example, if you don't have high load traffic, it's a good option. Now, what for example, for previous question, if you check, for example, H100 cards, there are those two cards, like VRAM is the same, but those memory bandwidth is different. And you can read this technical reports, I actually read it, but you are thinking, but what does it mean for me? For example, what actually changed? And those benchmarks is quite good. For example, you can select, let's say, Ollama 8D, and you can see in terms of tokens. And here is, for example, we have 85 and 81. So like different, only 4 tokens, very small, but price probably will be much bigger. And this is why you can decide that probably this one will be good enough for me. Because, okay, the memory is much faster, but for example, right now I cannot utilize it, and maybe this option will be the best. This is why I really recommended to check benchmark related with your cases. And about benchmark, this is a tricky topic because the idea is everybody, companies, vendors, or created models, like Llama reflection, for example, everybody try to do something and try to show that everything is good, And to be honest, it's really hard to find the place when you can compare, like the things which you can, for example, select about some models and compare and to have some trust to those numbers. And this one looks quite good. Well, this is probably the best one which I found and which I personally use. So the idea is you can select some, for example, model card and compare, for example, right now is like 200s and 100. We see some numbers. Okay, about hardware. Next step about software. So software means we have this model, we have GPU like hardware, and we need some piece of code to make it available, like serving this model. This is why we need this piece of code. In terms of this part, we have different options. Actually, it's much more. So it's actually start with Hugging Face TGI, later Ollama, it's quite popular. vLLM is standard, TensorRT LLM, and SGLang, it's quite new. There are some another I will show as well. But the whole story is like this. If you just try and you don't know how to start from Ollama. And this is can be quite good in terms of your personal use or let's say production for 1.5 people. If you have it more or less like this, production is good options. If you have more, I guess LLM is better in terms of production. TensorRT LLM it's quite good in some benchmarks, but it's really hard in terms of maintenance. And for example, this like you should convert one model from one state to another. For big models, it took some time, and so on. Another thing, what is about how LLM why it can be good. So this is kind of like metrics. If you check on GitHub how many stars do you have, you can see this yellow one. It's about stars which you pay for vLLM, and this looks like quite linear progression, and it will be. It is standard right now, but it will be. Nothing changed, I guess, in this area. Who use right now vLLM? Now, about tuning, it's quite interesting to listen if you can, because to run vLLM is quite simple. Like by vLLM serve and name of the model, that's all. But if you want to tune this, you have quite long the list, and one options here can improve, and one of them can destroy your configuration. This is why it's not easy to understand the whole picture because all combination works a bit different. Now about something new. There is something like NanoFlow. It's kind of new engine. Like you see, the paper appeared in the end of the August, less than 1 month, and they show that it works better for their case if you have more requested. What they're actually doing? Oh, this is here's some steps which we have during generated new tokens, and as you see, some of them are not efficient in normal usage, wasted part, and they try to optimize it. You can read more detail what does mean all of those steps. In general, the idea is you have sometimes steps when we matrix have multiplication, or when you have vector multiplication, and those different steps require a bit different resources and managed resources. Now, another option which kind of interesting, a bit tricky, I don't use it, but I found this and I will just show you. So this is kind of compiler. Today, somebody asked about Java, Android. I remember the time when people say you run once and debug everybody, everywhere, something like this. Like, because it should work, but usually doesn't work, and you should debug it. But the idea is quite similar. Like you can compile this model, and later of this you can run it on different devices. In theory, it looks quite good. In practice, I'm not sure. But the idea is quite simple. If you have experience with this library, let's share later some notes. Maybe something good is happening. I don't know. Just to share this exists. About benchmark. So right now, benchmark is about software part. And here is we can see Llama model 8B, like small one, not too small. And here is some engine which we can use. For example, vLLM. It's, higher is worse and lower is better. For example, we see the vLLM works quite good. By the way, this is what I shown before, MLC LLM. Looks quite good on this benchmark, but what I said, benchmarks, it's good stuff, but real life is another stuff. And you should be decided you won't go on this with real life. Now, next. So we talk about hardware, we talk about software. Another piece to decide is about a model. If you don't know how to find some interesting models, here is some tips. You can go Hugging Face, sorted by trending, and you can see some models which looks quite good. Exactly, for example, green, what model is shown on first presentation was very interesting in terms of how is close to biggest llama, like 400 llama, is close to the screen, but this is only 72 parameters. In order to interface, sometimes you need to click on agreement and to wait some times, and for this, and after it generates some token. So the idea is, for example, Llama, you cannot use Llama for improved Google or some other. Usually they accept it. You should just wait like a few hours or a few days. But later, for some models to download it from Hugging Face, you don't need token. And this is why I show this slide. You go access tokens, create it in U1, and later read it. Next step, about optimization. Optimization is the biggest, for example, part here, because we have a few options. One option is about types. For example, normally, like a few years ago, models trained with float 3 and 2. Right now, it's quite big, not optimal. Usually, we use half precision or much, much lower. For example, like this, or if it's possible, we go on here. But not GPU, all GPU cards or CUDA subpart, for example, Q4. This is what question I heard before. For example, this is quite tricky question. If you have model and this model was saved like Q4 or 4-bit, but it can be slower than, for example, 8-bit. Why? Because if your GPU doesn't support Q4, what happened? They first from Q4 you go to Q5 or Q8, and later just calculate. So you have some overhead in computation. This is why sometimes you have lower model, smaller model, but it works slower than model 8. So the idea about here is quite simple. When you have floats, right? For example, 32 or 16, it's like 16 bits or 16 box carries 32 boxes. Or if you divide it by 8, you have 4 bytes and 2 bytes. This is quite important in terms of the most important question: how many GPU I need for some model? Do you have this simple formula? How you can answer? For example, let's say you have the biggest llama, like 400 billion parameters. How many VRAM do you need to run this model? Like quick calculation. You know how to do it?
There's a calculator on Hugging Face. It's roughly.
Yes, but I'm trying to show like you can do it like very simple way. This is why I show this slide as well. For example, here we have 4 bytes, right? 1 byte is 8 bits, right? And 32 divided by 8, you have 4 bytes. Here is you have 2 bytes. And now we just multiply by number of bytes. For example, if you have the biggest llama and you want to serve the biggest llama in this precision, you should multiply by 2. So you should have 800 more gigabytes. Right? If you have Q4, Q4 means like half bytes. So you should divide it by 2. So if you have Q4, for biggest llama, it will be like half, like 800 or 200 GPU. It's quite simple because there are some calculators, but those calculators calculated many different things. But the most important this part. And if you don't have the longest context and so on, it will be like 90% or 95%. It's about calculating by this. Maybe a few percent about calculating another stuff. Like simple formula how you can quickly calculate. And now, for example, you have the biggest llama, like 300, and you have precision Q4. So that means you need 200 GPU, 200 gigabytes. 200, and let's say you have H100. H100 has how many? 80. So I should divide it. 280. So how many cards do you need? 3 cards. 3 cards to run the biggest, at least the biggest llama with quantization before, like this. It's quite simple, but for me it's very useful. I try to when I think about this, I try to find the simplest formula for me, like how can we calculate how many VRAM I need to run. So another thing, here is, for example, let's check. So, for example, you have 8 bits, 8 billion parameters, right? So, if we decided on 2 bytes, this is 2 bytes, right? So, we should multiply 8 times 2, right? This is why we have 16, and so on. If you look in this way, you can see it's a bit different, like something different after dot, but it doesn't matter. Right now, it's more about scale. How you can calculate in seconds how many RAM do you need to run this model. By the way, in Ollama by default you have O4. Here is if you select some model, you have by default O4. About quantization, this is image from media blog. This is something for copy-paste. So here is some idea. For example, you have some value, and this value is use float precision, right? Like this. And later you can convert it in kind of thing. And what happens, you create kind of buckets, and you just move on those buckets. So this is, it's more complicated than the code, but the idea is simple like this. So this is about types. Second part, about optimization. There are different techniques which are really helpful in terms of optimizing. So one of them is flash attention. Flash attention number 1 and number 2 was created by one person, is this one. This is why this image appeared. Like a lot of LLM apps later reuse it, but here is like this one person who created. And third one, actually developed by many people, media, and so on. It's in July this year. Ollama use flash attention as well. So what you should remember, flash attention is really helpful in terms of resource management part. Another thing is flash infer. So right now I don't have plan to explain those things. It's more about there are some piece of technology or methodology which can help optimize resource management, and which it looks like interesting for me. I share it with you. What else? PagedAttention. This is actually what vLLM created, because when they started, the story looks like this. When you have normal GPU card, you can run one request and wait until the answer will appear. And if you have 2 users, one user will be blocked. If you have more users, it actually doesn't work. And in this way, they start thinking how they can do, how to optimize this process. And one of them was about optimizing by this mechanism called PagedAttention. The idea is like this. So when we talk about LLM, usually underhood is transformed. There are some creative stuff like Mamba, but it's like research right now. So most things which we use underhood in LLM, this is transformers. Transformers has 2 parts, encoder, decoder, doesn't matter. But one of the parts inside this transformer is like this key value cache, key value matrix. And what's actually happened when you generate next token, you multiply some stuff. And here is some video. And here is like this. And look like it works. So when you calculate the second on third one and so on, you again recalculate the same. You see, you recalculate the same stuff. And the idea is very simple. What if you will not recalculate it, but keep it in some cache, right? And here is with cache, you recalculate some stuff, and here is without cache with cache. And here is reuse of stuff. So the idea is quite simple. If you understand what to do, it's not big deal. And PagedAttention is more about inspiration like memory, page memory from Linux. The idea is you have this cache, and you want to keep it like 2 ideas, like logical blocks and physical blocks. So logically, it looks like normally you create new tokens and so on, but from physical point of view, you just have like some blocks, some physical array when you keep those things, and it randomly looks like this, but those way you manage more efficiently afterwards. So what next? Let's say, do we have time? because I want to show some demo, but let's say a few things and I will finish. So let's say you can run this model. I will show you if I have time. And can I make some big challenge with somebody else? So here is some interesting benchmarks. For example, Grok or Cerebras. So they tested Ollama 70 billion parameters in N100 requests. And this is what the numbers they have. So this is number of tokens per second. So you have like this. Quite big compared to others. It looks like quite big challenge. And another interesting idea, if we select bigger model, like 400, and Sambanova is actually not too popular company, at least for now, but it will be probably changed. They show that results very impressive in terms of the biggest by the way, Sambanova you can play around by yourself. They have some kind of cloud. You just register, selected the model, you can check. Like it's really works very fast. And a few words about security. This is a kind of important topic. And usually don't know how to start. What would happen with OpenAI? Usually they don't share a lot of things, but here is quite an interesting point just to read this article. And they generate some ideas what they do, and probably you want to do the same stuff as well. If I have some minutes, I will show you how we can run those stuff on RunPod. By the way, who used RunPod before? Okay, that's my people. So RunPod allows us to get GPU, and we can use this GPU for as we want. We have at least two options. One option is we can create pod. For this option, we create by time when this pod is active, and another option is serverless. Here, right? So let's say we want to create some code. So this and create some because I default download some models before. Like this. Later we can decide that, for example, do we need H100 or can we use a smaller card? For example, let's say we will pick bigger one. Let's keep this one. So here is, we can put some information. The first of them is about Llama cost. Where is it? So first, for example, about Llama cost, you can copy 000. Here. And second one, various model I already downloaded. I downloaded before, and one more thing, we can copy port as well, like here. Okay, and just create it. And now what happened? Actually, spot will be active, for example, in a few seconds. And after this, we can use this GPUs as we want. The main point is here, what I said before. When I tried, for example, like a few years ago, try to get some GPUs in the big cloud, usually it's much more complicated. Here it's just a few clicks and it works. You also can run it by some Python library, quite simple. So here is how we can connect it. Yeah, here is we are under hood. Now, if you type Ollama doesn't exist because it's actually you can prepare your Docker later. Right now I have just simple Docker without almost anything. I have only a torch and something like this. So you just can install Ollama. It's quite simple. But later you can prepare your Docker and just reuse. By the way, they have Docker which you can reuse. For example, this one, like better Ollama the 12. But I don't like reuse big images because they download something. I don't know what is under hood, and much better just to pick a simple one. And if you want, you can add it later by yourself what you really need. Because if somebody added, probably this is you don't need it most of them. So okay, we have Llama. Let's run this. Okay. Screen doesn't exist here. So now just get to run those stuff. So the first comment is about serving. So Ollama serve right now, this we running this engine. It will took some few seconds. It will looking for a GPU. Probably that not get found. Here is it's found GPU. Here is the space which we have available. Bit less than 80 GB, but it's normal, it's not usual. Almost more or less. And for example, right now, if we provided Ollama list, so you can see which model. This model I downloaded before. So for example, we have the smallest Llama, we have a bit bigger, and the biggest one. As you see, this is what I tried to explain. We have by default, Ollama has quantization pool 4. That's why we have half of this. You see this and this a bit more than half, but like half. And for example, let's say we want to run this model. It's sometimes. Here we can see what's going on. Okay, and now we're just running some code and it works and it's without things. So first of all, what I said, if you have a really small task like you want to run for production for 1.5 person, Ollama is good enough. This is what happened right now. And another thing, if you have a bit more people and you need more production solution, the good idea will be used, for example, vLLM. It's kind of standard. And for example, for this will be, we can run this as well on RunPod, but also we can use serverless. Before I created the serverless, so the idea is quite simple. I decided which images I need. I decided about workers. For example, right now I have one active worker. It can be more. And for example, if you have more people, for example, right now everybody will use it. It will be create new workers. Right now it's actually 3 the maximum, but it can be much more. And in this way, you can manage the scaling process, and you pay only when you use it. And let me show you the usage. Maybe, for example, when we talk about normal API call GPT, it's like this, right? And when we talk about runtime, it's almost the same. Almost the same. What is changed? We decided, for example, another model. For example, right now I use this one, and we should create API key and called API key, and that's all. It changed the theorem. Now, when we calling this, it should be used. Here is the utilization sample right now. So let me sum up. What's the most important things from those presentations? Ollama inference is the stage which happened in the end, because one is train model, another one is uses model. Before, uses model was like the last step. It's worked in some way, because another part of LLM world was destroyed, because how to build model, how to fine-tune model, and so on. Right now it's more stabilized, and it looks like it works, and more people want to utilize it. So most people want to use what already created. This is why the phase like inference is quite important. And we think about inference, there are at least 5 steps, 5 decisions from your side. One of them is about hardware, you should buy or rent. Second one about software, and if you don't know what to use, you use Ollama or vLLM. Another part is about optimization. You should decide about quantization, about different tricks. I show you, for example, a lot of parameters in terms of Ollama, and plenty of them doing some crazy stuff, especially if you talk about interaction, those parameters. Another thing is about model. Decide which model do you want to use, and as we see, models, it's very dynamic area. For example, Queen model, it works really nice in terms of quality, but it's much less required memory, because actually the Queen model 17B, if you use Q4, it will be like less than 40 gigabyte RAMs. Probably it's not works good enough, because if you quantize the model, you usually works worse and worse, but there is some trade-off which can be acceptable as well. And last thing about API, usually you want to keep the API compatible with OpenAI, because it will be very easy to exchange different model, different software. In terms of architecture, it's very nice and very nice way to approach. And those probably all from my side. If you will need some information, presentation, so on, yeah, let me invite to join or send invite to my video. So, thank you.
Thank you very much for your presentation. Are there any questions?
Hi, Vladimir. Brilliant presentation as usual. Okay, so you just shown how to deploy the model on a run pod on GPU. So as we know, it's great to train the model on GPU due to parallel processing. However, isn't that true? Is that pretty sufficient to run the model which is already trained on CPU?
You mean if you train model on a large language model on CPU?
Yes. If you have already trained the model on GPU, isn't that true that it's pretty sufficient to run a trained model on CPU, or we still need GPU to run?
Two things. First, it's a bit interesting idea to train LLM models on CPU. Probably a pretty small tiny model like nano-GPT or something like this, right? Because normal models probably is not efficient. But another thing about data types, and it's more about to keep those to train during the train model. you can keep those data types in different precision, right? For example, 4 bytes, 2 bytes, you can change and so on. And usually you should be careful about this. So if you keep according to some standards, for example, quantization method, you have some process how you train the model and keeps less precision information. And for my knowledge, it's not about CPU or GPU. It's more about keeping consistently stuff. But again, for me, like training those models on CPU sounds like you can try, but it's like not real story. It's more like Toy Story. For example, you can try train the very, very small model, tiny model. Yeah, I don't know, like 100 million parameters. I don't know, I answered the question, but for me, it sounds like.
Yeah, about training, that's pretty clear. Yeah, but what about just run the model which is already trained?
Inference by using CPU.
Yeah.
Okay. Okay. So you can try about inference using by CPU. You will need, of course, RAM, like normal RAM or something like this on chips. You can use normal RAM, and it will be slower for sure. But let's say small models which propose today, it will be works quite good enough. Like few tokens at least, seconds.
Another question.
Great presentation, Vladimir. I just wanted to add that Ollama uses Llama CPP, and Llama CPP behind the, like under the hood, already does mixed inference. So it uses both your CPU and GPU. That's one of the advantages of using C++. So, yeah.
Yeah, I have like an open I have an open question. So like all those providers like Google and Amazon and so on like give GPUs, but the only winner here is actually the company in which office we're in today, right? All of the others are losing money. So I really like wonder, I don't know the answer, but why doesn't NVIDIA just sell it by itself and doesn't sell it to Google, but do it by itself?
Yeah, I don't know how it works because, you know,
okay.
You cannot buy GPU cards on the half-long free cards and that's what you have available. But on the other hand, for example, in this year, some restriction with China, they updated this chip and they sell 1 million cards. 1 million, not 1,000, but 1 million. And some capacity exists. I don't know how it works because it's more about business. It's more or less about technical work.
It's about selling shovels instead of digging yourself in the hole. Like you had the gold rush, we call it easier, because you don't take risks.
Okay, I would have another question. You mentioned the MLC, like an inferencing engine or like solution, as a solution to like run inferencing on different platforms. How does it compare to ON and X? Because I remember that was like a try to find a common ground for like different models to run on different platforms.
I don't use MLC in production. This is I don't know all the details, but for me it's more low-level stuff. Like you compile things in something like low-level representation. And on Next, it's not about compiling. It's about you change your presentation, but this is you keep.
Yeah, like you would convert like a final model to on NX standard, and then you would run the it on the inferencing engine. But I remember that they want to like share the inferencing engine on different platforms as well.
It's about Onyx. It's more about like, let's say you have different models, not only let's say neural network. For example, you have XGBoost, and different other models. And for example, you train those models and you want to share it later. And Onyx is kind of adapter which allow you make it. But when we talk about LLM models and those compilers, for me, it's like two different things. We can compare those. And those MLC, it's more about compiling stuff. Like like looking for like any byproducts.